Okay, so let us continue. So now what we are going to do is see how to insert a new node to a binary search tree and delete a node in a binary search tree. Because you see, a binary search tree should satisfy a certain property, right? So the data for the internal node should be greater than or equal to its left child and less than its equal to its right child. So you cannot just arbitrarily insert a new node anywhere in a binary search tree. You have to insert it in an appropriate location. Similarly, if you want to delete some node, we have to rearrange the binary search tree in such a way that it is again coming back as a binary search tree after the node is removed. So that's why we have to insert and delete nodes in a certain way. So that's what we are going to see now. Alright, so let us start with insertion. So this is the rule. So given a binary search tree, you're given some new node, the data of that node, say 24 is the data you want to insert in this binary search tree. So let k be the data that is to be inserted. So what we are going to do is traverse the binary search tree as if you're going to search for the data k. Okay. So let us traverse this binary search tree as if you're going to search for 24. So start with the root. 24 is the data we want to search for, is what? Greater than the root 21. So if at all 24 is in this binary search tree, it should be to the right of 21. So go to the right subtree. The data, the root node here is 78. 24 is less than 78. So if at all it's there, it should be to the left of 78. So go to left of 78, which is here. Compare 24 with the root here, 23. If at all 24 is here, should be to the right of 23. So go to the right, 34. 24 compared with 34. If at all 24 is there, it should be to the left of 34. So we have reached a node. When we come to a leaf node or a semi-internal node, we insert to its left or right depending on the case. If there's a tie, we insert a node as left child. So we are here. We cannot go further down. We want to go to the left, but there's no data node to the left. So we have reached a leaf node. Okay, and now there's a tie kind of thing because we could either insert it to the left or right, but when you want to apply the rule, right? So 24 is the data, 34 is the root node. So 24 should be to the left. We cannot really insert to the right. So there's not even a tie here. You have to insert 24 to the left. Okay, so insert 24 to the left of this. So this way, this is a binary search tree. Is that clear? So simply traverse the binary search tree as if you're searching for 24. So 24 compared to 21, 24 is greater than 21. So go to the right. 24 less than 78, go to the left. 24 less than 23, sorry, 24 greater than 23, so go to the right. 24 less than 34, so this is a leaf node and we have to insert the left or right depending on the case. There's no even tie here because this is 24 is less than 34, so it should be to the left. Okay, so let us do a few more examples. So this is the binary search tree. We want to insert 8. So let us repeat the process. 8 is what? Less than 21. So go to the left. Then 8 is again less than 21. Go to the left. 8 is less than 9. So now we are here like this. So we are here. 8 is less than 9. We have reached what? A semi-internal node. Remember, a semi-internal node is an internal node that has only one of the two child nodes, either a left child or a right child. So here node 9 is a semi-internal node because it has only a right child. So we have come to a semi-internal node. We insert to its left or right depending on the case. Now 8 is less than 9. So we have to again insert 8 to the left of 9. Okay. Now let us say, okay. So far in the previous two examples, we were inserting a data that is not there. Like 24 is not here, so we went through the process using this procedure I have listed here. Similarly, 8 is not here. So now we want to insert some data that is already there. Okay, so 21 is the data we want to insert, and there is at least one node with data 21. So how to go through the process? So the rule is this: if the data to insert is already there, then proceed to its left subtree. But so actually the overall process is you will again kind of search for 21 in this binary search tree. So you're starting the search process to the root, and the root itself has 21 there. So that's why we meet this condition that the data to insert is already there, then proceed to its left subtree. So we kind of know the properties. The data for any internal node is what, greater than or equal to the data of its left subtree or left child, and less than or equal to the data of its right child. So that equal to is what is applying here. So we go to the left subtree, and that's how we break the tie. So now we are here. So again search for 21. So 21, again the root is 21 here. So just go to the left subtree. So we are here. So then compare 21 with 9. 21 is greater than 9. So if at all 21 is there, it should be the right of 9. So go to the right of 9, which is 12. 21 is greater than 12, right? So we are here. And this is a leaf node. So now we have to decide whether to insert the left or right. Since 21 is greater than 12, we have to insert 21 to the right of 12. Okay. Alright, so let us do one more example. You want to insert 78. So start the process from the root node. Now 78 is what, greater than 21. So we have to proceed to the right. So now we are here where the root node of the subtree is same as the data we want to insert 78. So the rule is if you come across the data to insert is already there, proceed to its left subtree. So go to the left of 78. So we go here, compare now 78 as usual with the root node of the subtree 23. 78 is greater than 23, so go to the right. Then this will be like what? 34, 78 again is greater than 34, so we have reached a leaf node, and 78 is greater than 34, so it should be inserted to the right of 34. Right, so last example. So we have 34 to insert. So again 34 is greater than 21, so go to the right. 34 is less than 78, so go to the left. 34 is greater than 23, so go to the right. So we are here. So this is a scenario where you have a tie, because this is 34 and the data you want to insert is also 34. So we could insert 34 to either as a left child or the right child of this leaf node 34. So here I break the tie, as I say somewhere in the rule, break the tie in favor of the left child, right? So if there's a tie, we insert the node as a left child. So that's what I'm doing here. So there's a tie here, so insert 34 as a left child of this 34. Okay, so this is how you insert a data in a binary search tree and still retain the whole thing as a binary search tree, right? So let me stop for a minute.